Hello guys, welcome to my channel. In this video, we will cover the topic Fourier series. In 1822, J.B. Fourier gave a theorem according to which any complex periodic function can be analyzed. According to his theorem, any complex periodic continuous function fx may be expressed as a series of sines and cosines in the form given by the equation 1, where a0, an and bn are the coefficients of Fourier series. Now, to evaluate these coefficients of Fourier series, we will use the orthogonal property of sines and cosine functions, which is given by minus pi to pi sine mx cos nx dx is equal to 0. Now minus pi to plus pi sine mx cos nx dx is equal to, we can write it as cos mx cos nx dx equal to pi delta mn, where m and n are not equal to 0, and this value will be equal to 0 when m is not equal to n, and will be equal to pi when m is equal to n. Now to evaluate a0, we will integrate equation 1 between the limits minus pi to pi. So equation 1 becomes minus pi to plus pi fx dx. We have integrated this part of the equation 1, so it will become minus pi to pi integration fx dx. Similarly, a0 minus pi to pi dx, since a0 is a constant quantity, so we will take it out of the integral, plus summation n equal to 1 to infinity an minus pi to pi cos nx. We have integrated this term. An is constant, so we have taken it out of the integral. Cos nx dx plus summation n equal to 1 to infinity bn minus pi to pi sin nx dx. Now, since all other integrals vanish like cos nx, if we will solve it, we will get a0 pi minus pi plus summation n equal to 1 to infinity an. Now if we will integrate cos nx, we will get sin nx minus pi to pi. Since sin pi is 0, so this term will be equal to 0, and in this term we will write summation n equal to 1 to infinity bn cos nx upon n minus pi to pi. So this term will become cos n pi minus cos n pi. So cos n pi minus cos n pi will be equal to 0. So we will only have this term, that is a0 into pi plus pi. Minus will become plus, so we will get 2 pi a0 fx dx, and a0 will be equal to 1 upon 2 pi. We will cross multiply this 2 pi this side, so it will become 1 upon 2 pi minus pi to plus pi fx dx, and this is the equation for finding the value of a0, and this is the value of a0. Now to evaluate an, we will multiply this equation with cos mx on both sides, and then integrate between the limits minus pi to pi, that is minus pi to plus pi fx cos mx dx. We have multiplied fx with cos mx and then integrated it with between the limits minus pi to pi. Similarly, we will do on this side a0 minus pi to pi cos mx dx plus summation n equal to 1 to infinity an minus pi to pi cos mx cos nx dx plus summation n equal to 1 to infinity bn minus pi to pi cos mx sin nx dx. This part will become a naught. The integration of cos mx is sin mx upon m minus pi to pi. For solving this integral, we will again use orthogonal property, which states that minus pi to pi integration of cos mx cos nx is equal to the integration of this part will be equal to pi delta mn plus summation n equal to 1 to infinity bn. Here also we will use the orthogonal property, which states that integration from minus pi to pi of cos mx sin nx is equal to 0. So a naught sin mx sin pi is equal to 0, so this term will be equal to 0 plus summation n equal to 1 to infinity an pi delta mn plus this term is also 0. So we are left with summation n equal to 1 to infinity an pi delta mn. Since there is integration, so we will cancel this summation from here. We have used integration, so this summation will get cancelled. This term we can write it, the term an delta mn can be written as am pi. So minus pi to pi fx cos mx dx. So am will be equal to 1 upon pi minus pi to pi fx cos mx dx. Now we will put m equal to n, so we will get an is equal to 1 upon pi minus pi to pi fx cos nx dx. So we have got the value of an, this an. Similarly, we will evaluate the value of bn. Now to evaluate the value of bn, we will multiply equation 1 by sin mx and then integrate it between the limits minus pi to plus pi, that is minus pi to plus pi fx sin mx dx is equal to a naught minus pi to plus pi sin mx dx plus summation n equal to 1 to infinity an minus pi to pi sin mx cos nx dx plus summation n equal to 1 to infinity bn minus pi to pi sin mx sin nx dx. Now a naught integration of sin mx will be equal to cos mx upon m minus pi to pi plus, here also we will use the orthogonal property, according to which integration of sin mx cos nx from the limits minus pi to pi is equal to 0. So this whole term will be equal to 0 plus bn, and here also we will use the orthogonal property, which states that integration of sin mx sin nx from between the limits minus pi to pi is equal to pi delta mn, where m and n are not equal to 0. So now here cos m pi minus cos m pi upon m, when we have put the limits, substituted the limits from pi to pi, plus bn pi delta mn. Now this term will be equal to 0, cos m pi minus cos m pi will be equal to 0. So we are left with bn pi delta mn. Now bn delta mn can be written as bm and multiplied by pi. So we will get the value of bm from here, that is 1 upon pi minus pi to plus pi fx sine mx dx. Now we will replace m with n, put m equal to n, so we will get bn equal to 1 upon pi minus pi to plus pi fx sine nx dx. So this is the value of bn. So we have all the three coefficients, that is a naught is equal to 1 upon 2 pi minus pi to pi fx dx, an is equal to 1 upon pi minus pi to pi fx cos nx dx, and bn is equal to 1 upon pi minus pi to plus pi fx sine nx dx. So we can find the Fourier series of any function fx by substituting the values of these coefficients. Thank you for watching the video. If you like the video, please share it with your friends. Thank you.